Hi everyone, welcome to Leetcode programming. In this video, let's try to solve the problem Kth missing positive number. So let's check the problem description. Given an array of positive integers sorted in a strictly increasing order and an integer k, find the kth positive integer that is missing from this array. So the elements from the array will be in strictly increasing order. That means the element will be in sorted order plus there won't be any duplicate numbers. So the numbers in the array will not be repeated. So that's what strictly increasing order means. So let's look at the examples. And as mentioned here, the numbers in the array will be positive integers. So you don't have negative numbers. So we have 2, 3, 4, 7, 11 and we need to find fifth missing number. So if you start from, we need to start from 1 because the numbers are positive numbers. So 1 is missing, we have 2, 3, 4, then 5, 6 is missing, 7 we have, then 8, 9, 10 are missing, then we have 11. So if you count the missing numbers, so first missing number is 1, second missing number is 5, third missing number is 6, and fourth missing number is 8, and fifth missing number is 9. So the fifth missing positive number is 9. Second example, we have 1, 2, 3, 4. So every number from 1 to 4 is present. So there is nothing missing in the given array, but we need to find second missing positive number. So you need to start your counting after the array. So fifth and sixth elements are the missing numbers and 6 is the second missing number. So in the constraints we have array length can be from 1 to 1000. Again the value of array numbers can be from 1 to 1000 and k also can be from 1 to 1000. And as mentioned earlier, every number array of I will be less than array of j if I is less than j. So they will be in strictly increasing order. So as we have seen in the examples, the first example, the missing number is within the array range. So if you consider the range of array from 2 to 11, then the missing number is between 2 to 11. But in the second example, the array is outside the range of the missing number is outside the range of array. So the range here is 1 to 4, but our missing number is 6. So basically we need to consider two cases. So the missing number can be within the array range or it can be outside the array range. So just scanning the array may not be sufficient to find the missing number. So let's look at a few examples. Let's discuss in more detail. So let's say we have an array like this, then we have one more array and k here is some 5, k here is some 2. So let's k here is 1. So your first missing number will be 3 here, so it will be within the array, whereas your fifth missing number here will be 4 plus 5, 9. So but you have to go beyond array. So basically you need to scan 9 elements here, whereas you need to scan 3 elements here. So ideally if we have array size of array as 10 and we have k, then we need to scan a maximum of n plus k elements to find our answer. So we will scan through n plus k elements, we will iterate through n plus k elements and find our kth missing number. Let's write some code. Let's start with Java solution. We just have to keep in mind the two conditions that we have discussed. It can be within the array range or it can be beyond the array range. So let's define n as array dot length plus k, because our answer will be between 1 to n. Let's take an index. Let's define an index to iterate through our array. Then let's scan through I equal to 1, I less than or equal to n, I plus plus. So we check every number from 1 to n. So n being array length plus k. So our answer will be within this range 1 to n. And every number we need to check if it is present in the array. So if index will start from 0, array of index is not equal to I, the current number I, that means we found one missing number. So what we can do is we can decrement our k. Else case means array of index is equal to I, that means we have a number in the array. So we need to check the next number. So current number is present in the array, so we need to check for the next number. So we just increment index, and finally when we reach k equal to 0, that means we have checked all the missing numbers. Then we return our I. So current I will be our answer. So whenever we find a missing number, we decrement our k. So whenever we reach k equal to 0, we return current element, because current element we are looping from 1 to n. So I will be our answer. And anyway, there will be there will always be answer. So we never reach this condition. So we just return -1. We can return anything because this will never reach. We always return from here. So our answer will be there always. So we return from here. So this looks fine, but there is a problem here. So n here is array length plus k. So your index can go beyond your array size. So we need to add a check for that. So if idx is greater than or equal to array dot length, or so if it is greater than or equal to array length, then decrement k, or if it is not equal to I, then decrement k. So if it is greater than array length, then we don't enter here and we don't get a exception. So let's so this should work fine. So let's execute and check. Yeah, it works fine. So let's submit the solution. Yeah, so runtime of 1 milliseconds and all the test cases have been passed. So let's look at C++ solution. So let me copy the code because it is almost same. So let's change it to array dot. We can in fact use array dot length, or we can use array dot size. Anything should be fine. And rest everything remains same. Let's execute and check. Length, 1 second. Yeah, so let's use size. This is not this is a vector, so let's use size number. It works fine. So let's submit and check the time complexity. Yeah, so 16 milliseconds and the solution has been accepted. So let's look at time complexity. Let's see the worst case complexity. Let's say we have an array of 1, 2, 3, and let's say size equal to size of n, and k equal to some 5. Let's say it's equal to m. Then in worst case, you are going to iterate through 8 elements. So 1, 2, 3 plus 5, 8 elements. So your worst case complexity will be O of 8, or O of m plus n. So time complexity here will be O of m plus n, and space complexity is 0 because O of 1. So we don't use any additional space. So it will be O of 1. So thanks for watching. That's it. Thank you.